Principles of Finance with Excel Modeling, Copyright Lou Gaddis. Topic 3, Issues in Capital Budgeting. In this topic, we're going to talk about the IRR rule and talk about when it can be misleading. Compare the NPV of investments of unequal lifespans by incorporating something called effective annual cost. We'll also incorporate unequal cash flow payments dates and calendar dates into capital budgeting problems. And we'll evaluate lease and buy decisions. And while we're doing that, we'll learn some new Excel functions. First of all, let's talk about cash flow patterns. If we have conventional cash flow patterns, and I'll define those as in which the sign only changes once in the pattern of cash flow. So look at this one right here. Start off $100 and then all positive cash flows. Sign changes once from negative to positive. Here's another one, negative, negative, then they switch to positive. So the sign only changes once. And here's another one, positive, then switches to negative at the end. So even though this one may look a little funny, in this case, you'll get a consistent 1 IRR estimate for each one of these patterns. The trouble you get is when you have some irregular cash flow patterns. And here's one here, in which the signs change once, more than once. So we'll look at this one here. You have an initial payment, a positive cash flow, it turns negative, turns positive again. So whenever the cash flows change signs more than once, what you're going to have is more than 1 IRR. So let's take a look at this example. I'm going to grab this from Excel. And I'll put it into my workbook. So here's an example in which it's a sanitary landfill. You're going to pay $800,000 to buy it. You're going to get paid $450,000 a year as people pay you to dump garbage. And then at the end, you got to do some work to fill up the landfill. So you have a negative cash flow, positive, switch sign once, and then it switches signs again. So let's calculate the IRR and then NPVs of this investment. So we'll first calculate an IRR like we've always done it. Just do IRR, put in the cash flows, and it looks like 2.68%. So that doesn't look like a great project. But let me do this. Let me actually look at a bunch of our discount rates and calculate the NPV. So let's say the discount rate can go from 0%. I'll just put in 0% and 3%. I'm going to hold down, select both those numbers and copy it down, incrementing by 3%. So what if the discount rate is anywhere from 0 to 36%? Let's calculate the NPV of this cash flow. So I'm going to do my NPV. I'm going to put in this rate here, comma, and the cash flows from years 1 to 6. I'm going to hit F4 to anchor those. And then we also have to take care of the initial cash flow, $800,000. I'll anchor that. So there's my NPV, minus $50,000. So what I'm going to do now is copy that down and get 13 NPVs. And what you see, as long as it looks like the discount rate is between about 3 to 27%, you get positive NPVs. However, it's negative if it looks like a little bit below 3% and a little bit above 27%. Now let me graph these NPVs. I'm just going to insert a graph. So now we can see our NPVs. And let me add an axis. Do a right click, select data. Let me click the horizontal axis and put in the IRRs. So now you can see that the NPV is positive as long as it's above about 3% and below about 27%. Now here it calls into question the whole concept of IRR. Now normally we talk about the IRR as that discount rate which made the NPV 0. So it looks like the IRR is about 3 or about 27. There's actually 2 of them. And this happens when you have more than one change in the sign of cash flows. So here's what we're going to do. We're going to actually use the IRR function again, except we're going to guess. Well, we're going to put the values in. I'll anchor that. And then I'm going to guess a value of 3%. And you can see then 2.68 is this point right here. By not putting a guess, it's using 0. So if I put in a guess of 0, I'll also get 2.68%. But however, if I put in a guess of, say, 27%, that must be that other intercept. So this problem has two IRRs. So in that case, this just builds another argument that you should be using NPV to evaluate the projects. So I would say any NPV between, say, 3% and 27%, I would accept this project. Well, now let's take another issue with capital budgeting where we have trouble. What if you're thinking about buying one of these newfangled lights that are really expensive but last a long time and use a lot less electricity, but they're really expensive, versus the old cheap ones that burn out really quickly and use lots of electricity? The problem is this light bulb, this fluorescent light bulb, lasts about 10 times longer than this one. So even though the operating costs are a lot cheaper, if I did just an NPV of buying this light bulb versus this one, I'm not sure this one would show up as being cheaper. So let's take a look. Here's some data. I'm going to copy this information. And I'll put it into Excel. And let me change the column width to see this a little bit better. And let me change the row widths, make it a little smaller. All right, so here we go. Whoa, that looks a little long. So we have our incandescent lights, and here are our assumptions. First, let's use a discount rate. We're going to calculate an NPV at some point of 8% per year. And let's assume that the cost per kilowatt hour for electricity is 10 cents per kilowatt hour, which is a reasonable estimate based on where you live. It would be a little different. Let's say this normal light bulb here is 100 watt. And we're going to compare it to one that has about the same amount of brightness, number of lumens, which is this 15 watt fluorescent bulb. Now this bulb is really cheap. It costs $1. And if you use it about 250 hours per month, the bulb has about 1,000 hours of life. It'll work for about 4 months if you leave it on for about 250 hours per month. Now the monthly cost in electricity, if I take the number of hours used per month times the watts times the cost per kilowatt hour, it turns out to be about $2.50 per month to use this bulb. Now if I do the same thing with my fluorescent bulb, first of all, those bulbs have the same brightness, same number of lumens, and it has 15 watts, so it's going to be much less electricity. However, the bulb costs about $5. If I still use it the same amount of time, say 250 hours per month, however, this bulb lasts about 10,000 hours before it burns out. So that $5 gives you 10,000 hours, which is about 40 months. Not 4 months. So this bulb, although it costs 5 times more, lasts 10 times longer. And if you see here, if I take my 15 watts to get that brightness, it only costs about 38 cents a month in operating expense. Now, if I do a traditional NPV analysis, I'm not sure what the answer is going to show. So if I do my NPV, so I'm going to actually do an NPV. I'll start out by taking the cost of the bulb, $1. Now, what I need to do is do an NPV of 4 months of operating this bulb. Now, I can't use the NPV function because I don't have a list of cash flows anywhere. So what I need to do is I'm just going to use a present value function, take the present value of 4 months of operating this bulb. So I'm going to do a PV. It looks like it wants the rate. So I'm going to put in the monthly rate. I'm going to anchor that and divide by 12. So my monthly rate is 8% divided by 12. Now it's asking me for the number of months. So I'm going to put 4 months, comma. And then I'm going to put in the cost, minus $2.50 is the monthly cost. So what this is going to give me is the present value of $2.50 per month for the next 4 months, discounted at 8% divided by 12. So the present value of operating this bulb, including its cost, is $10.84. Now if I copy this down to this bulb, as long as I anchored the rate, This one has a present value of $18. Now, why is the present value so much higher? Because it cost more, and even though this one is much cheaper per month, it's there for 40 months. So the present value of a 40-month annuity, including the cost of the bulb, is $18. So this would lead me to say, well, let's buy this cheap bulb. It seems to be a lot cheaper. That's the problem with traditional NPV analysis. Again, even though I called this NPV, I used the PV function because I didn't have the set of cash flows in which I can just highlight. So I'd use the present value of the 4 positive cash flows. So here's how we adjust it and see really which bulb is the cheapest. Let us convert these present values into monthly payments that incorporates the time value of money. So what I'm going to do is now do a payment function, equals payment, PMT. Put in my monthly discount rate. That, I'm going to anchor it, divide it by 12. Now, this bulb lasts 4 months. And the next parameter looks like present value. I'm going to put in the present value that we just calculated of 1084. So now what this is calculating is if I have a present value of 1084, what would be the monthly payment over 4 months? Now I can repeat this for this bulb. What would be the monthly payment incorporating the time value of money for operating this bulb? So what we see now is this bulb it looks like it's 5 times cheaper. So even though this has a present value that's lower, this is spread over 4 months. This present value is spread over 40 months. And the monthly payment is 52 cents versus 275. So now it is quite clear this bulb uses much less electricity and lasts a long time and offsets its higher price. So that's how we can compare projects of different investment horizons. Let's talk about another issue in capital budgeting that's sometimes difficult to kind of wrap our heads around. What if we talk about buying a simple piece of equipment? It's going to cost us $4,000 and we're thinking about just doing a purchase using company cash. We'll call that an all equity purchase. Equity meaning we're using the corporation's funds to purchase the asset. And we're going to depreciate it over 3 years. So what we're going to do is create a depreciation tax shield. You're going to save some taxes because of depreciation. So you're going to pay $4,000 today and receive some benefit of depreciation tax shield over 3 years. However, you could you could lease it. And if you lease it, the lease expense will be $1,500 payable today, and then payable for the next 3 years to operate it for three years. So it's actually 4 payments. However, this $1,500 is tax deductible. In other words, it's an expense. So my after-tax cost is going to be less. Now the last one's going to be a little more difficult. Is what if I don't lease it, but I actually purchase it, but then purchase it using a loan? Now that gets more complicated. Because now I'm going to purchase it and amortize it like the first one. However, I'm going to finance it with a 3-year loan. In that case, the IRS allows you to deduct, or corporations deduct, interest expense before calculating tax. So just like in the first case you have a depreciation tax shield, in this case you have also kind of an interest tax shield that goes along with the expense. So let's take a look at this example. I'll grab the spreadsheet. And go to Excel. And let me just move this up. All right, so here are our examples. The machine's going to cost us $40,000 today. We're going to depreciate it over 3 years using a straight line depreciation. We're going to compare that with a $1,500 month or lease that's due today in the next 3 years. There's going to be 4 total payments. I could borrow at 15%, my discount rate for NPV is 17%, and the corporate tax rate is 40%. So let's look at the NPV of the cost of purchasing using, we'll call it all equity. You just use cash from the company to purchase it. So it's going to cost me $4,000. That's immediate cash flow. Now the next cash flow that this purchase is going to generate is I'm going to have a depreciation. If I just take $4,000 divided by 3 years, the depreciation expense is going to be $1,300. Now that's not a real expense. However, when I take the depreciation amount times the tax rate, I will pay $533 less in taxes because I'm able to deduct that $1,333 from my revenues before calculating taxes. So my cash flows from the purchase and depreciation of this asset are going to be $4,000 today, cost, save taxes for the next 3 years. There's my depreciation tax shield. So I can now calculate an NPV. I'll take my discount rate, let me anchor that, put in my 3 cash flows in years 1, 2, 3, and then add the initial cash flow. So in present value terms, NPV, the cost of purchasing it, all equity, is $2,821. Well, let's compare that to the after-tax cost of a lease. Now on this lease, the way it's structured is you pay $1,500 today. However, after tax, that's only going to cost you $900. All right, so in some sense, it's like another tax shield. By having any expense, you're going to shield the corporation from taxes. So the after-tax cost is $900. All right. Well, one way of thinking about that is that $900 really has 2 components. I'm going to pay $1,500. However, that $1,500 is also going to create a tax shield. If I just take the expense times the tax rate of $600. So the reason why it cost me only $900 is I paid $1,500 for the lease, but I'll pay the government $600 less at tax time. So, or I can just write it this way. So that is my after-tax cost of the lease. I can then just copy my NPV function since I anchored the rate, and it looks like this is a little bit more expensive, $2,888. So this looks like a better deal. Right? I want to minimize the present value of costs. Now here's an interesting way of doing it. What if I do an equity purchase? I buy it for $4,000 today. I'm going to depreciate it. I'm going to actually link up here. I'm going to get my depreciation tax shield. However, I'm not going to use the money's, the firm's equity or cash. I'm actually going to borrow, have the corporation borrow $4,000 using a 3-year loan at 15%. Now, if I do that, that annual payment for that loan, I'll do a payment function. I'm going to be $4,000 for 3 years. Whoops, let me put the interest rate in there. Interest rate is 15% annually for 3 years. And I'm borrowing $14,000. So I'll actually pay $1,752 to principal and interest if I get a 3-year loan of $4,000. Now I can copy that. That's going to be an even payment every year. However, when I go to calculate taxes, only interest is going to be tax deductible, because in some sense the principal is already taken care of in depreciation. So let me get the interest component of that payment. I payment will tell me, it's an Excel function, I payment will tell me how much of this payment here composed interest and how much is principal. Every payment in a loan involves paying interest and paying off some of the principal. So if I put in my rate again, borrowing cost 15%. Now we're asking how much interest is in the first payment. So I'm going to actually put $ signs around the interest rate up here, the borrowing cost. However, in period 1, I want to see the interest component in period 1, 2, and 3. So I'll leave that unanchored. There are a total of 3 payments, and the present value is $4,000. I'll anchor that. So of the $1,752, $600 is interest in the first year. In the second year of that $1,752 is $427, and the third year $229. Now I could use the P payment function to figure out the principal in each month, or I can just take the total payment minus the interest, and you could also see that of this payment of $1,752, in year 1, $600 was interest, $1,152 was principal, payoff of principal. All right, and then you have years 2 and 3. Now let's calculate the actual cash flows. So let's first of all talk about even though I paid a loan of $1,752, $600 will create a tax shield. All right, I don't pay the full $600. So let's actually get the after-tax loan. The after-tax loan is there's no tax break on the principal, but the $600, I'm not going to pay 100% of it. I'm going to pay 1 minus the tax rate. The tax rate's 40%. I'm going to anchor that. So I'm actually only going to pay 60% of it. In other words, it's going to create a tax shield. So the after-tax cost of this loan is only $1,512, $1,580, and $1,660. So this is the after-tax cost of the loan. This is the actual purchase and depreciation cash flows. So, and notice there's no cash flow up front from the corporation standpoint because they bought it and spent a $4,000 but got $4,000 from the loan. So my cash flow is just going to be my after-tax loan payment plus the depreciation tax shield. So these are the cash flows from buying it with equity but financing it with a loan. I can then calculate the NPV, and it's 2305, and what you see is this is the best option for buying this equipment. I'm going to use equity financing. In other words, don't do a lease. I'm actually going to buy the asset, but I'm going to use a loan to secure the funds. All right, so I shouldn't have said equity financing. I'm going to do a debt financing. This is a debt financing of the asset. This is a leasing the asset. In some sense, the leasing company is financing it for us. And this is simply purchasing it, but getting no advantages of the interest rate tax write-off. All right, so that's how you evaluate a buy versus lease versus financing. Now, a little note on earnings, taxes, and depreciation. So I know a lot of people get confused with this. So here's a real simple example. So a company had operating revenues of $300, operating expenses of $200, and the tax rate is 40. Let's do a real simple income statement. 300 minus 200 gives me earnings before tax of 100. Multiply 100 times 40%. I pay $40 in taxes. It gives me earnings after tax of 600. Now I can write that in a formula as revenue minus cost, 100, minus revenue minus cost times the taxes. So in other words, 100 minus 40. But I can rewrite that as just the revenue minus cost, and I just get to keep 60% of it, 1 minus the tax rate, right? The tax rate's 40%. So I could just say 300 minus 200 times 60%, 1 minus the tax rate, is the after-tax income. So it's just another way of writing the formula. Now in this case there is no depreciation, so that's also equal to my cash flows. All right, when there's no depreciation, these are real expenses and real revenues. In other words, cash flow expenses and revenues. Now let's make up another example. Everything's the same, but you have this depreciation. Remember, depreciation is a recognition of a historical CapEx, but it's not a real expense. I never write a check to pay depreciation. All it is a line item in the income statement that you deduct before calculating taxes, and it's used to calculate earnings after tax and taxable income. So everything else is the same, 300 minus 200, but I get to subtract $50 of a non-cash expense, which gives me an earnings before tax of 50. I then calculate taxes of 40% of 50, which is $20. So I have an earnings after tax of $30. So look what happened is the earnings after tax went down because I have more expenses, but my taxes also went down from 40 to 20. Now I could rewrite that a couple different ways. I could take revenue minus cost minus depreciation minus the tax on those items, or write it as revenue minus cost minus depreciation times 1 minus the tax rate. In other words, I get to keep 60% of that. So I could write it different ways to get me to the number of 30. But let's talk about cash flow. This example here, although the profit is less, generates more cash flow. So let's look why. If I take my earnings after tax, $30, but I need to add back the one expense I didn't really write a check for. I never wrote a check for depreciation, so I'm going to add that back. So actually the cash flow would be my earnings after tax, including the depreciation, but then I need to add back the depreciation, so the cash flow in this case is $80. Well, let me write it one more time that maybe helps you make sense of all this. In some sense, this was my revenue minus costs and taxes here. So one way of rewriting the cash flow is to pretend there was no depreciation and just put that number down, 60, right? I just took this 60 and put it there. And then what's the real effect of this $50 depreciation? Really the only effect is it saved us taxes. Right? I used to pay 40, I pay 20, and that depreciation tax shield is $20. And how you calculate a depreciation tax shield is you simply take the depreciation expense, $50, times the tax rate, 40%. That's $20. That is what's going to save me. That's the difference between this 40 and 20. So I can just pretend it's no depreciation and add that $20 depreciation tax expense to get an $80 cash flow. So I know a lot of people get confused with this idea of depreciation not being a real expense and earnings versus cash flows. So I hope hopefully this made some sense. Now we're going to do something else. Let's talk about a project that costs $10,000 today. It's going to generate quarterly cash flows for 5 years. And the quarterly cash flows are actually $750 per quarter, which is $3,000 per year for 5 years that you're going to receive quarterly. And the discount rate is 15%. Let's calculate the NPV of that. So let's grab this. All right, so let's talk about doing our traditional NPV. And let's just pretend, it's kind of a pain to write quarters in, so let's just do things annually. I pay $10,000 today, and I'm going to get $3,000 a year, even though I know it's paid $750 per month. So let's just pretend it happens at the end of the month. Let's put $3,000 there, and then I'll just link that up. So, just say, hey, it's close enough, right? And we'll just do our NPV. Equals NPV, put in our annual discount rate, comma, put in the future cash flows, and then account for that initial payment. So it looks like the NPV is negative 177. So in other words, don't do the project, the NPV is 0. But wait, let's try to actually model the cash flows a little closer. Let's say they cost us $10,000 today, but now these are quarterly payments for 20 quarters, which is 5 years. So each quarter I'm going to get 3,000 divided by 4, 750. So in reality, it really looks like this, where these periods are quarters and not years. All right, well, I can calculate the NPV of that. I'll take the NPV. Now, since we're dealing with quarters here, I have to take the quarterly rate, which is just 16 divided by 4. All right, so the quarterly interest rate is 4%. Put in my future cash flows. And account for the initial cash flow. Oh my goodness, look at that. Now I want to do the project. So what's happening is the fact that I'm making the cash flows quarterly is increasing the present value of the cash flows. Right? This used to pretend I didn't receive one cash flow for a year. Now I'm receiving 3 cash flows before a year. So that's what the NPV turns positive. And we'll do one more thing. If you know the dates, you can even get more precise. Say we'll put in today's date. Equals now gives you a date. Gives me today's date. Say 8/30, August 30th, 2016. And say we're going to get the cash flows exactly over every 90 days. So let me just take that plus 90. So every 90 days, this generates a cash flow, which is about a quarter of a year. Now we can take a present value, but we can let Excel actually get the exact fraction of time. So let's copy the cash flows again. We'll just pretend they look exactly like this. All right. Oh, I don't need that, since we're just assuming every 90 days. All right, now what we do is Excel has a function called xNPV. In xNPV, you just put the annual discount rate. Doesn't matter if it's quarterly, because it doesn't know what it's going to do there, because you can put any kind of dates in there. That's my annual discount rate, comma, S for the values. Now the values, you can put in an initial cash flow. You don't have to skip the first one, or the period 0 cash flow, comma, the dates. So now you have an NPV of 443. And if the cash flows are indeed every 90 days, this is your real NPV. So I think what we take from that is when possible, you always want to use the most accurate timing. So in today's topic, we talked about how the IRR rule can be misleading when the signs change more than once. We compared the NPV of investments of unequal lifespans by using that payment function to calculate the monthly costs or annual costs. We incorporated unequal cash flow payment dates and calendar dates into Excel. And we looked at lease versus buy decision. And we learned about the date function in the xNPV.